Hello everyone, welcome back to my channel. I'm Chinmaya Shetty from Sri Venkateswara College of Engineering. I'm going to tell about additional list operations, sparse matrices, and doubly linked list. Linked list operations. Traverse. It accesses each element of the linked list. Insertion. It adds a new element to the linked list. Deletion. It removes the existing elements. Search. It is used to find a node in the linked list. Sort. It is used in the nodes of the linked list. Traversal linked list. Displaying the contents of a linked list is very simple. We keep moving the temp nodes to the next one and display its contents. When temp is null, we know that we have reached the end of the linked list. So we got out, so we get out of the while loop. Insert elements to a linked list. You can add elements to either the beginning, middle, or end of the linked list. Insert at the beginning. Allocate memory for new node. Store the data. Change next of new node to point to head. Change a head to point to recently create a node. This is the programming, a small program have been displayed here. Insert at the at the end. Allocate memory for new node. Store data. Traverse to last node. Change next of last node to recently created. And the small program has been displayed here. Insert at the middle. Allocate memory and store data for new node. Traverse to node just before the required position of new node. Change next pointers to include new node in between. On this insert at the node, the small program has been displayed here. Delete from a linked list. You can delete either from the beginning, end, or from a particular position also. From deleting from beginning is point ahead to the second node. Head is equal to head next. Delete from end. Traverse to second last element and change its next pointer to null. The small program has been displayed here. Delete from middle. Traverse to element before the element to be deleted. Change next pointers to exclude the node from the chain. The small program has been displayed here. Search an element on a linked list. You can search an element on a linked list using a loop using the following steps. We are finding an item on a linked list. Make head as the current node. Run a loop until the current node is null because the last element points to null. In each iteration, check if the key of the node is equal to item. If the key matches the item, return true, otherwise return false. Sort elements of a linked list. We will use a simple sorting algorithm, bubble sort, to sort the elements of a linked list in ascending order below. Make the head as the current node and create another node index for later use. If head is null, return. Else run a loop till the last node. In each iteration, follow the following step 5 and 6. Store the next node of current in index. Check if the data of the current node is greater than the next node. If it is greater, swap current and index. It is the program of sort linked list. sparse matrices. It is a special case for a matrix in which the number of zero elements is much higher than the number of non-zero elements. As a rule of thumb, if 2 by 3 of the total elements in a matrix are zeros, it can be called a sparse matrix. Sparse metric representations can be done in many ways following are two common representation, array representation and linked list representation. Using arrays, 2D arrays used to represent a sparse matrix in which there are three rows named as row, column and value. Row index of row where a non-zero element is located. In column index of column where non-zero element is located, and the value non-zero element is located at index. Using linked list, using linked representation of sparse matrix. Row index of row where non-zero element is located, and then column index of column where non-zero element is located. Value of the non-zero element is located at index and the next node address of the next node. Double A linked lists. It is represented using the linear arrays in a memory where each memory address stores three components data value, the memory address of the next element, the memory address of the previous element. Advantages of double linked list over the singly linked list. A double linked list can traverse in both forward and backward directions. The delete operations in double linked list is more efficient if a pointer to the node to be deleted is given. We can quickly insert a new node before a given node. In a singly linked list, to delete a node, a pointer to the previous node is needed. To get this previous node, sometimes the list is traversed. In DLL, we can get the previous node using the previous pointer. Disadvantages for double linked list over a singly linked list is every node in a double linked list requires extra space for a previous pointer. It is possible to implement a double linked list with a single pointer through, though all operations require an extra pointer previous to be maintained. For example, in insertion, we need to modify previous pointers together with the next pointers. For example, in the following functions for insertions at different positions, we need one or two extra steps to set the previous pointer. Applications of doubly linked list. It is used by web browsers for backward and forward navigation of web pages. LRU, least recently used, or